This is the third video in my fastbook-benchmark series, and I'm going to focus on full-text search. The first video was a dataset overview. The second video went through document processing, so converting notebooks into chunks. And in this video, I'm going to do a basic search implementation using full-text search. The key imports here are SQLite 3, and I'm also importing the same items that I did in my second video because I'm going to need that text chunking and processing code. I've also put all of my helper functions in this utils.py, which you can find in the examples folder in my repo. And the document processing video, here are all the functions and code that I used there, so I'm just trying to use up less space in my notebook for these videos. So the first thing we're going to do is we're going to download our data. And this will return a dictionary with my chapters and notebook names. I'm going to pass that to my getData function, and this is going to load those notebooks as JSON files or objects, chunk them into strings, into 2 or 3 chunks, and pass back a dictionary. So with that set up, I can now load my database. I'm going to set up some of the hyperparameters, so to speak. I'm calling my SQLite database fastbook.db. The chapter of intro for this first round is going to be chapter 1. And just going to make sure everything looks good, which it does. Okay, so the first step is to create a virtual table, and I'm just going to copy this code that I know runs because I had some issues with that before. I'm going to check that the database doesn't exist, so I can rerun this cell. This is just kind of boilerplate code to connect the SQLite database. I'm getting a cursor, and then I'm executing my query. And this is it. This is all I have to do. I create a virtual table called fastbook_test, and I just use using FTS5, and I give it the column names. And that's it. With this FTS function or keyword, it will know that it's going to perform, BM25 scoring on this text column, and it'll automatically create a rank column which contains the negative of that score, so that when it's doing it and when it orders by rank, it has the highest score match first. So very simple to get this rolling. So I'm going to run that, and the data that I want to load into my database are going to be the documents, and these are going to be the processed documents, so they're going to be the chunks with chunk size of 500. And I know that these documents are going to be 57 documents long, and that is correct. So the next step is to actually load this data into the database, and I've got code ready for that as well. So again, my usual connection and cursor. Now I iterate through each document in my documents, and I run this command. So I insert into my fastbook text, and I'm inserting the chapter and the text, which is the chunk string, and those are parameters, and I pass it the chapter and the doc in this for loop. I'm going to commit that, and then I'm going to run this select statement so that I can check that indeed my number of results does match. And I'm going to put here the length of documents. So I run this, and it is not happy because, why is it not happy? Let's see. Let's delete this. Let's run this again. Let's run this. Okay, cool. Not sure what the issue there was there, but just running it again got me the result. And if I look at one of these query results, look at the first one. Here we can see the chapter, and here we have the text. And this is indeed the very first chunk that exists in chapter 1. And if I compare this to my documents, it should be the same. Let's expand it, and we see that, yeah, it starts out with hide, and algorithms to diagnose illness and disease, algorithms to diagnose illness and disease. So it looks good. So a couple of helper functions that I'm going to create. I'm going to create a delete DB function, and this is going to delete my database, so I can easily run that every time I need to just refresh. Okay. And then I'm going to wrap all of my functionality that I used before into this load data function. So I'm going to go back up here and copy this code. And that's going to create my virtual table if it doesn't exist. And then this is going to load the data in. And if this works, I want to pass, or I want to return true. So I'm going to run my experiment again. So I'm going to say delete DB. And now I'm going to go through each chapter and corresponding text in my data dictionary. Let's just copy this from up here. And instead of chapter 1, I'm now putting my text. And then I'm just going to say assert load data documents DB path and chapter. Let's see if this runs, and it does. Great. Okay, so I now have loaded up all of my chapter chunks into my SQLite database. So the next thing I'm going to do is I'm going to load the keywords. And these are Claude-generated keywords, Claude Sonnet. And I have them in my examples file, or examples folder in the repo. I have this FTS keyword CSV, so you can check it out there. Just to show you here, here are my FTS keywords, and here are the keywords that Claude generated for me. And I haven't actually iterated on these keywords, so that's another opportunity of improvement for these retrieval results. So I'm going to get my keyword dictionary, and I know what size it is, so I'm going to make sure that it's loaded in correctly. And we're going to take a quick look at it as well. Okay. All right, so that looks great. The next thing we have to do is we have to take these keywords and we have to prepare a match string so that we can pass it in to our SQL query to run FTS on our virtual table. So this is the goal. So this deep learning, math, data, computers, PhD, I want that to become a string that says deep or learning or math or data or computers or PhD. So I want this kind of string. So I'm going to start by pulling one row of my keywords data frame. Okay, so that is correct. I'm going to grab the chapter which should be chapter 1. I'm going to grab the question text. Just so we can see what we're asking. So the question is, do you need these for deep learning? Lots of math, lots of data, lots of expensive computers, a PhD. And no, you don't. That's the spoiler alert. I'm going to grab my keywords. And this is string, so it's not a list yet, it's a string. And I'm going to take those keywords, I'm going to replace these double quotes with an empty string. So I'm going to get rid of my double quotes, and then I'm going to split. And let's just save that and take a look, make sure that looks as expected. So now I have each of these words are captured. A couple more things that I have to do is I'm going to create my match string. I'm going to join on this or string, and I'm going to take each of the keywords and I'm going to put a double quote around it, and I'm going to strip the comma that's on some of these words. I'm going to make sure it ends with a double quote, and then we're going to iterate through this. So if we look at our match string, this should be what we have as our goal. And I think it is, yeah. So each of the keywords is surrounded by double quotes and is separated by an or. Okay, so now we can actually run search. I'm going to copy my query so I don't make any typos. And very straightforward, I'm going to select the text chunk and the rank from my virtual table. And this is the key point. Where fastbook text match, and this is going to be my match string that I provided. And I'm going to query by chapter. I'm going to order by rank, and then I'm going to pick some limit. And in all of my experiments so far, I have used a limit of 10, so I'm just going to keep that as what I've done. And then I'm going to grab this, and I connect to my database. I execute this query, which is Q. I provided the parameters, which are the match string. This I had to make sure it was a string, so I wrap my chapter inside the stir method, and I give it my limit. I fetch all, and then I just grab the first item, which is going to be the text. So I'm ignoring rank for now. So I run that, and that looks good. And we look at, in this case, it was the second string, which we can see that, okay, yeah, here's the answer, what you don't need to do deep learning, and here's all the answers to those questions. So the last thing I'm going to do is I'm going to wrap all this up into my full text search function, and I'm going to have all results, which is an empty string, and then I'm going to do my database connection, which is there. Instead of doing one row, I'm now going to go through each of the rows in my keyword data frame, and I'm going to grab the chapter. Let's see, so here's the chapter. I'm going to grab my keywords. And I'm going to apply the same string methods that I did as before. So I'm going to say replace and split. And I'm going to create my match string just as I did before. So this will iterate through keywords and strip the comma and add the double quotes. And then I'm going to add my query. And that's not how let me copy it from here, because sometimes I've found some issues when I don't format it correctly. So there it is. And what else do I need? I need my actual execution of the query, and I need this list comprehension. Okay, and then I'm going to make sure that the length of my results for a given question is less than or equal to my limit. And if it is, then I'm going to append it to my all results. And then once it loops through all of the chapters and closes the database connection, I'm going to assert that the length of my results is the length of the keyword data frame. Basically, I'm doing a check for the number of questions, and then I'm going to run all results. And let's test this out. My chunk size should still be 500, which it is. I'm going to delete the database. I'm going to run this code again. So let me grab this. Okay, so this should give me a fresh copy of my database. And now all I have to do to run full text search is just call full text search. And let's just run this again, just so we're confirming that I do have 191 lists of 10 retrieved passages. Each list is going to be for each of my 191 questions. And then let's look at the first question and the second passage, which should be this one, as expected. Okay, so a couple of final notes. I'm going to put my load data and my full text search functions inside my utils.py so I can use it again in the next video, where I'm going to show my approach to scoring retrieval results using my modified MRR and modified recall functions. So thanks for watching, and I'm looking forward to doing the next set of videos here in this series. Thank you.